All right, so the first topic that we are going to look at this year is transformations. Okay, now this is going to be the first thing that we look at, but you will not only see this in this unit. You are going to see these transformations come back over and over and over and over along the course of the year. So make sure that you are learning these because they are really important. Okay, so basically, here's the situation. This is what we're going to use to look at how the transformations work. Okay, now this is an equation particular to a quadratic, a degree 2 polynomial. Okay, but these transformations work for everything. Okay, the y and the x are your regular variables. Okay, and then all these other letters, the k, the a, the b, and the h, those are all going to be replaced with numbers. And each number is going to tell you a particular thing that's happening in the quadratic. Okay, so for example, this k value right here. So this k value, what that controls is that controls a vertical shift. Okay, so that controls a vertical shift in your parabola. So basically what that's going to do is it's going to take your parabola and it's going to slide it up or down depending on what number you fill in there for the k value. Okay, now similarly, if we jump over to the end to where this h value is, okay, this h value here, that one is a horizontal shift. Okay, so what that is going to do is it's going to slide your parabola left and right, okay, depending on what number this is. Okay, so one thing to notice about both of these shifts is notice that there's a minus sign built in here. Okay, so because this minus sign is built in, that throws people off. Because if I put a positive 5 in here, that tells me that I'm going to have a vertical shift that's going to push me up 5. I'm plugging in positive 5, so I'm shifting vertically 5. But when you look at what the equation looks like, it's going to say y minus 5 because the minus is built in. So what happens is people see this and they look at it and they say, oh, it says y minus 5. I go down 5. No, you go up 5. The minus was already there. 5 is the k value. Okay, so basically how I think about this, that's my dog, Pepper. Pepper, hush. Okay, basically how I think about these is I just think of them like they're backwards of what they look like. Okay, so if it says minus 5, I think, oh, it's backwards, so I go positive 5. Okay, when it says plus 2, then I think, oh, it's backwards, and I go minus 2. Okay, so that applies to both of these. All right, so those are those two values. Now let's talk about what A and B are. Okay, so A is one that you're going to see a lot. The A value is going to be a vertical, and it does one of three things. It could shrink your graph, or stretch your graph, or flip your graph. Okay, so if you can sort of envision using some like putty or something, and you can envision making a little parabola, okay, when you have a number in here, a vertical shrink, what that's going to do is it's like if you take that putty parabola and you smush it, right? Think about what's going to happen. It's going to make it kind of short and fat, right? That's what a vertical shrink will do. A vertical stretch would be like pulling on your Play-Doh. Okay, well, that's going to make it tall and skinny, right? So that's what a vertical stretch is going to do. And then a flip, exactly what you think it would be. A U-shaped parabola is going to become an N-shaped parabola. Okay, and the way that you're going to know which one of these three things is happening, it's a vertical shrink if your A value is less than 1, so a half, 0.5, negative 0.3, okay, would also count as a shrink. When I'm talking about these A values, I'm really more talking about the absolute value, okay? The negative, okay, anytime you have a negative value, that is going to be when you have your flip. Okay, so if it was like negative 1/2, the negative would tell me it's flipped and the 1/2 tells me it's a shrink. Okay, if that A value, and again, we're talking about the absolute value, so I'm ignoring the negative. If that's bigger than 1, then it's going to be a stretch. Okay, so a negative 1/2 would be a flip and a shrink. A negative 5 would be a flip and a stretch. Okay, and so I kind of separate those. Okay, so that's a vertical, shrink, stretch, and flip. Now, these three transformations, those are the big ones that we're going to worry about right now. We are going to talk about this B value, but that is not going to be a major focus of this chapter. We will come back and deal with the B value a little bit more intensely with some other transformations in further units. It all works the same way, but I think it's just a little bit to overload you with at this point in time. So we're not doing terribly much with the V value, but basically what that is, and I'm sure you could kind of guess this, is it's going to be your horizontal shrink or stretch or flip. Okay, now the weird thing about this is your flip rule is exactly the same as this guy. Okay, if your B value is negative, that's going to be a flip. And for a parabola, a horizontal flip doesn't make a difference, right? It's still going to be a U-shaped graph either way. Okay, so that's another reason why we really don't worry about this too much in this unit. Whereas with some other shaped graphs, you will see that come into play. Okay, but here's the weird thing about horizontal shrinks, stretches, and flips. If your A value is less than 1, that's a vertical shrink. But if your B value is greater than 1, that's going to be your horizontal shrink. So it's a little bit backwards. So if I had a 1/4 here, okay, that's not going to tell me it's a shrink. That, a B value less than 1, is going to be a stretch. So if I put 1/4 in for B, that would be a horizontal stretch. And if you kind of, again, picture with your putty, you're pulling it this way, it's going to get wide and short, right? If the B value is less than 1, if its B value is greater than 1 for a shrink, so if you have like a 5 here, right? Picture that U, if you take that putty and you shrink it in, that's going to make it tall and skinny. Okay, so that's what your B values do. And again, I'm not really going to deal with that too much this unit. We'll come back to that later. All right, so let's look at how we actually use these in some equations. So first off, we're going to talk about 4 basic shape graphs. Okay, so 4 parent functions is what they're called. The first ones are parabola. That's the name of the shape. Okay, it's a quadratic equation. Okay, so you'll hear both of those words. Your basic equation is that it's y equals x squared. Okay, and when we look at what the graph of that looks like, a quick little dirty table of values here going from -2 to +2. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So when I look at what these look like, plotting these points, I'm sorry, this didn't print very well on my printer. It's a lot more clear on your note packet that you printed out, or that you can print out. But this is what this graph is going to look like. All right, and you know what? I'm actually going to add in -3,9 and 3,9 on here, just to give you that last little bit. Okay, so that's going to come up here-ish. Okay, so there's my parabola. There's that U-shaped graph. Okay, and it just kind of looks like that. Okay, so this is my parabola. Right, now here they want you to write the equation for a parabola that's been shifted up to left 1 and stretched vertically. So thinking about what that's going to do to this graph is it's taking this graph, we're moving it up 2 to the left 1, and then we're stretching it vertically. So this is going to be like a taller, skinnier parabola that's going to be over here. Okay, what's my equation going to look like? All right, so let's plug some stuff in. So it's going to be y, and then I'm going to have my vertical shift. Well, it's been shifted up 2. So it's going to be y -2. Okay, and again, this is where I was talking about that backwards thing. The minus sign is built in. So when you look at this, you might be tempted to think, oh, it says y -2, it goes down 2. No, it actually goes up 2 because that minus sign is built in. Okay, then the next thing we have is our vertical shrink, stretch, or flip. That's our A value. We've been stretched by a factor of 3. So that's going to be a 3. Okay, there's no horizontal stretch, so I don't have to worry about that. So I'm just going to have one set of parentheses. And then in here, it's going to be x minus, well, it's been shifted to the left 1. Left, that's -1, right? Up is positive, right? You're shifting in a positive direction on the y-axis, so we just put in a regular 2. But here we're shifting to the left 1. That's along the negative axis, right? So I'm going to have to plug in a -1. And of course, we aren't going to leave it like that because that looks terrible, right? So we're just going to make that into a plus sign. Okay, and then don't forget your squared on there. The squared is what tells you that it's this type of graph. So it tells you it's that parabola shape. Okay, so that's my equation. All right, so let's look at our next type of graph. So down here, an absolute value graph. Okay, you remember absolute values. Those are the ones where it looks like those bars on either side of the x, right? And basically what it does is it's the distance from 0. Okay, so it tells you the distance a number is from 0. So when I look at my table of values over here, just making a quick little one, right? How far is -3 from 0? 3 spaces. How far is -2 from 0? 2 spaces. How far is -1 from 0? 1. How far is 0 from itself? It's not. How far is 1 from 0? 1. 2 from 0? 3 from 0. Okay, so it basically makes them all positive. So when I look at what this graph looks like, this one is going to be sort of similar in shape, but this one's more V-shaped than U-shaped. So there's my -3, 3. Here's -2, 2. Here's -1, 1, 0, 1, 1, 2, 2, 3, 3, right? So this one's going to be more of a V shape when compared to the parabola that's more of a U shape. Okay? All right, so then writing this equation, write an equation for the absolute value function. So that tells me I need these bars. Shifted down 5, right 3, and shrunk horizontally by a factor of 3. Okay, so horizontal shrink by a factor of 3. So y minus, then I put in my vertical shrink, stretch, or flip. Well, it's been shifted down 5. So -5. Okay, and again, we're just going to pretty that up, make that a plus. Okay, equals, I don't have any kind of a vertical shift. I do, in this case, though, have a horizontal shrink, okay? And we said that a horizontal shrink is when your b value is greater than 1. So even though this is kind of weird, you're just going to plug in that 3, okay? It's bigger than 1, which is what tells me it's going to be a shrink, okay? And then from there, it's going to be times x minus h. So x minus my horizontal shift. Well, this has been shifted to the right 3, so +3. Oops, but I messed something up. This isn't supposed to be a parenthesis, right? It's not a quadratic. This is where we're going to put in those absolute value bars. Okay, so the only thing that's going to be a little bit different is that instead of having parentheses, like I did in this example up here, I'm going to have absolute value bars instead. And there's a square in this. There's no square here. That's not part of the function. Okay, so that's the only thing that changes. And that's why we cover so many different transformations all at the same time. This will work for just about everything. You just have to change maybe what the shape of the grouping symbols are and maybe what the exponent is. All right, cubics. What does a cubic equation look like? So a cubic equation is going to be y equals x to the third. Okay, so when I take a look over here at what my graph looks like, so -3. All right, so when I put these in, 3 to the, or -3 to the third power is going to be -27. -2 to the third power is going to be -8. Okay, -1 to the third power, -1, 0 to the third, 1 to the third, 2 to the third, 3 to the third. Okay, so where these previous two graphs were symmetrical, this one's not quite symmetrical. There's definitely a relationship between these two numbers, but it's not going to be quite symmetrical. Obviously, I'm not going to be able to fit -27 on here, so let's just jump in with -2, 8. So -2, -8 would be down here, -1, -1's about there, 0, 0, 1, 1, 2, 8. So here's what this graph looks like. It's sort of a funny thing that's got a weird squiggle in the middle, but that's what your cubic graph looks like. Okay, you can see another one over here that's been printed. All right, and we're going to take a look at these and say, all right, well, how has this graph been transformed? So what I'm going to kind of look at when I'm looking at how a graph has been transformed is I want to look for a key point and basically just track where that point goes. I like to choose the point that goes through the origin, if at all possible. So I'm going to take that point right there and say, well, where is that over here? Okay, well, over here, it seems to have ended up there. That's where that point went. Okay, so what happened from here to there? Well, I went left 3 spaces, right? It was at 0, now it's gone to the left 3 spaces. It was at 0, now it's gone down 1. So it's gone left 3, it's gone down 1. And then to figure out if there's any kind of a shrink or a stretch here, I want to kind of compare where that is with another point. Okay, so here, to go from this point to this point, you go over 1 and up 1, right? So I want to look over here and say, well, if I go over 1 and up 1, am I going to end up at another point? Yeah. So that tells me that I haven't had any kind of a transformation vertically or horizontally. Okay, so those are my two transformations. All right, and then last but not least, our square root equation. Okay, so the square root equation, I always find that this graph looks really, really funny, personally. I just think it's sort of an odd looking graph. So what this equation is, y equals the square root of x. Okay, and when we kind of look at this, I don't have a graph on here for some reason, but if we take a look at what our table of values is going to be, and you think about this, right? If I start at 0, I can take the square root of 0, that's 0. Square root of 1, 1. I can do that. I'm going to skip 2 because I can't really square root 2 nicely. I can't square root 3 nicely. So the next number I can really nicely square root is 4. So that's going to be the next thing I put in my table, and that's 2. And the next one after that would be 9, right? Square root of 9 is 3. But if I try to look at these negative numbers, like say -1, what's the square root of -1? Well, there isn't one, right? There's no number times itself that equals -1. Later in the year, we're going to talk about imaginary numbers, and then we'll start dealing with some of those square roots. But for now, we're just going to say, nope, there isn't one. So there's going to be nothing on that side of the table. So what's this graph going to look like? Well, here's 0, 0. Here's 1, 1. 4, 2 is going to be out here somewhere. 9, 3 will be out here somewhere. So it's going to kind of look like this. All right, and what this shape actually is it's technically really a parabola, right? See how these numbers right here are just the backwards of the table that we just had, right? 0, 0, 1, 1, 4, 2, 3, 9, 3. Okay, 0, 0, 1, 1, 4, 2, 9, 3. Okay, so basically what this kind of looks like is it looks like if you took that parabola, you took that U shape, right, and you chopped off one half of it, and then you kind of flopped it over on its side. That's sort of what this shape is here. Okay, so that is your introduction to how transformations work. Okay, it is really important that you know these. This is something that you're probably just going to have to sit down and memorize and just grill yourself until you've got these nailed. Okay, so know these different transformations, know what each one does, and remember about that built-in minus sign. Don't let that throw you off.